So here we have our mostly cleaned up starter motor, and we're going to identify some of the parts and pieces associated with it. So the big one, and one of the big things that differentiates a starter motor from a regular motor, is this guy right here on top, this big cylinder here. This cylinder is known as a starter solenoid. Now, it's actually two components built into one. There's a high contact switch, and it's electromagnetically operated, so that when power is supplied to this terminal here, and you have ground in the case, it closes some contacts. Basically, it draws this bar up and bridges this contact here to this contact here. This basically is your high contact circuit, sends battery power that comes in through here, through the contact and to the motor. That activates not only the armature through the brushes, but it also activates the field coils that are on the outside of this case. Now, I said it's twofold in its design because when it does this and it makes contact here, it also has a plunger that lives inside this case here, and you can see the pivot pin. And what happens is, as it's drawn out like this, it goes like that, and there's a lever that kind of comes through this housing here that takes the gear, you can see here, and pushes it out. This makes this gear engage the flywheel only while you're cranking the car. So once you disengage power from here by taking your key and turning it back to the run position, it then disengages and also disengages the electrical contact in here and turns off your starter motor. So, like I said, the starter solenoid is the big thing that changes a changes a electric motor to a starter. Now obviously there's a housing and there's very specialized mounts and things like that per engine application, but without this is just an electric motor with a fancy gear and a fancy snout on the end. One problem area that a lot of starters have, especially here in the Northeast, is this terminal here. Now this one uses a solid metal copper bar that goes from our starter solenoid to the brushes and to the field coil assembly. A lot of other starters, they use like a woven copper, almost looks like a shoelace weave, flat wire that goes inside here. Those tend to break over time. They kind of deteriorate from the outside and they break, and then eventually one of the times you go to start your car, you put it, or you go to turn the key, and it sends high current through it, but there's not enough copper there to handle the load that the motor needs, and it burns out. When that happens, you're done. You don't have a running starter motor anymore. So this is actually a replaceable piece, the starter solenoid. You take out these bolts here and you can take this off and replace it with another one. They are available. When you send a starter motor out to get refurbished, a lot of times you end up with a new solenoid on it, new brushes, new contacts, maybe new field coils if they test bad, and then they reassemble it and you have a remanufactured starter motor. Now, this one says on, let's see, where was it? I think it was on this label before I started cleaning it off. It said it was remanufactured. So at some point in time in the past, this one had been gone through and checked and double checked and apparently triple checked because they want to make sure it's good. And this is a refurbished motor. So on top of that, what we need to understand is that this is our pinion gear, and that pinion gear engages our flywheel. The pinion gear is a small drive gear. It's doing the driving. The power is coming from your motor, spins this small pinion gear, and this thing's spinning at several thousand RPMs, probably like 2,000 RPMs. But because this small gear drives a large gear, it takes many revolutions of this gear to make one revolution of the entire flywheel or flex plate. And as a result, we get an underdrive ratio. It takes more revolutions of the starter motor to make one revolution of your engine. And by doing so, we multiply the torque applied to the engine. If you think about us ingesting air into an engine, compressing that air and igniting it, it takes a lot of force to do that. And the more cylinders you have, the more drag there is in your engine. The bigger the engine, the more resistance there is. And modern engines, there are a lot of high compression engines, and that takes more effort as well. So the underdrive ratio that's created gives us an advantage of torque by simply using a small gear to drive the large flywheel. So now let's talk about bench testing. A lot of times, when we're diagnosing a starting condition with a car that turns over slowly, there could be a couple of potential faults. One, we could have a starter problem. Two, we could have a voltage drop in the battery cables. Three, you could have a weak battery. And four, you could have problems inside the engine that are causing resistance to the whole engine spinning. And so what we would commonly do is do a bench test of the starter, kind of eliminating that, using process of elimination to take that out of the equation, and that either A, tells us that it's turning over slowly by itself and it's weak, or B, it tells us that it's something else. So bench testing a starter, something that should be done, usually before you put one back together in a car, especially if it's not the healthiest looking starter motor in the world. This one's halfway decent, but I've seen better. But what we're going to do is we're going to check two modes of operation. Not only are we going to check the motor for operation, but we're also going to check the starter solenoid to make sure it is in fact kicking out the pinion gear and doing what it's supposed to do there. So there's two ways to check it. One, we provide power here and ground to the case, and then we activate it with some sort of a bridge between here and here to close the contacts. And that'll operate everything all at once. That doesn't really give us a great idea of what's going on here. It does tell us that it does pass current through here, but everything happens all at once, so it can kind of be a little bit confusing. I like to, instead of doing it that way, I like to operate the motor and the starter pinion gear and solenoid assembly separately. So instead, I ground the case, then I apply power through my jump box to just this terminal, and that will make a loud clicking noise, basically kicking the starter pinion gear out and activating the solenoid. It tells me if that part's working properly. Then I move my positive lead to this terminal here, and I connect my ground to the case. By doing that, it's not kicking the pinion gear out, and I can just see how the operation of the motor is. So I will show you how that's done. So first we're going to test the solenoid. I want to make it so that you guys can see it. Right here is where the action is going to take place. There will be a loud clicking noise. So like I said, you're going to ground your case. Anywhere on this section here typically is the best place to do it, because that's where the solenoid grounds through. So if we connect it here, give it a little wiggle to make sure that it's good. Making sure that my jump box is off right now. Mine again is has a nice feature that you can activate it here at the box instead of just touching it and having sparks and stuff fly. So right now we're ready to test. I'm going to hold on to this because it's going to make a loud snap and it might jump a little bit. But as I turn this, you can see the pinion engaging and disengaging, engaging and disengaging. And so I know that it's working properly, it works quickly, it doesn't seem to hang up, it returns properly. That's what we're looking for. Engages and returns. Engages and returns. So it's pretty healthy. Next thing we'll do is we'll check the motor operation. So I'm moving my positive lead to the output of my solenoid, not the input, but the output. Wiggle it to make sure I got a good connection, and I'm going to activate it. And I'm just turning the switch on my jump box to activate this. Now you don't want to run these for very long because they do generate quite a lot of heat, and they're really only supposed to run for a few seconds. It's a good, fast speed. On motors that are a little bit weaker, they don't jump right up to that full RPM. Instead, they kind of start slowly and then pick up speed. And that's kind of an indicator that, yeah, this motor is getting weak, or it has internal resistance, like the bearings have got corrosion in them, or the bushings have some grit in there that's causing some problems. But this looks pretty good. So then the next part is testing the whole operation to make sure everything works together. In my case, I am going to take my clips and I'm going to bridge both terminals, the little one and the main feed. And then this way, when I turn this on, it should activate. I gotta hold onto this thing tight. Oh. That's what I was afraid of. Because this has a hinge in it. It's not passing power from this side to this side. So we're going to have to do it the old-fashioned way. We're going to provide power here, and we're going to bridge the terminal with a big old screwdriver. Sending power through the screwdriver to the starter solenoid activation post. And as you can see, it gets a little bit wild because we're making a contact on something that's moving around. If I had a vise here and I had this in the vise, it would be a little bit easier. But we can do it and make sure that it's working properly. And bad connections cause that to happen. And you can see the whole operation happen simultaneously, which I hope that kind of shows why I like to do them independently, so I can see them both doing their appropriate actions by themselves.